For centuries, humans have looked up at the night sky and wondered, how did it all begin? Was there a moment of creation, an instant where time, space, and matter were born? Or has the universe always existed, stretching infinitely through time? Today, we explore one of the most profound questions in science. Is the Big Bang just a theory, or is it fact? The Big Bang Theory is the leading explanation for the origin of the universe. It proposes that the universe began as an infinitely small, hot, and dense point, often referred to as a singularity, and has been expanding ever since. This idea might sound like science fiction, but it's backed by some of the most compelling evidence in modern physics. The story of the Big Bang begins in the early 20th century, when scientists first began to question the idea of a static, eternal universe. Albert Einstein's general theory of relativity, published in 1915, suggested that space itself could be dynamic, capable of expansion and contraction. Then, in 1927, a Belgian priest and physicist, Georges Lemaitre, proposed an idea he called the primeval atom, the concept that the universe had expanded from a single dense point. His idea was largely ignored at first, but everything changed in 1929 when American astronomer Edwin Hubble made a groundbreaking discovery. Galaxies were moving away from us, and the farther away they were, the faster they seemed to be receding. This was the first observational evidence that the universe was expanding, just as Lemaitre had predicted. So, what evidence supports the Big Bang Theory? Scientists rely on three major pillars. 1. The expansion of the universe. Hubble's discovery of redshift, the stretching of light from distant galaxies, showed that the universe is expanding. This expansion suggests that, if we reverse time, the universe would have been smaller and smaller until it reached a single point. 2. Cosmic microwave background radiation, CMB. In 1965, physicists Arno Penzias and Robert Wilson accidentally discovered a faint glow of radiation coming from all directions in space. This was the afterglow of the Big Bang, remnants of the heat from the universe's birth, still detectable today as microwave radiation. 3. The abundance of light elements. The Big Bang theory predicts that the early universe was so hot that only simple elements like hydrogen and helium could form in large quantities. Observations confirm that these elements make up about 98% of the visible universe, aligning perfectly with Big Bang predictions. Despite its strong evidence, the Big Bang theory is often misunderstood. Let's clear up some common misconceptions. The Big Bang was not an explosion. Many imagine the Big Bang as a fireball bursting in empty space. In reality, it was the rapid expansion of space itself. There was no outside for it to explode into. The Big Bang does not describe the absolute beginning. While the theory explains how the universe evolved from an incredibly hot and dense state, it does not tell us what caused the singularity or what came before it. The universe is not expanding into anything. Instead of galaxies moving through space, space itself is stretching, carrying galaxies with it, like dots on the surface of an inflating balloon. While the Big Bang theory is widely accepted, it is not without challenges. Some physicists explore alternative models, the cyclic universe. Some propose that the universe goes through endless cycles of expansion and contraction. The multiverse hypothesis. Others suggest our universe is just one of many, each with its own unique origins. Quantum gravity theories. Since the Big Bang singularity defies the laws of physics, some theories attempt to merge quantum mechanics with general relativity to explain what happened at the very beginning. So, is the Big Bang just a theory, or is it a fact? The answer lies in how science defines these terms. In everyday language, a theory might sound like a guess, but in science, a theory is a well-substantiated explanation based on evidence. The Big Bang theory is the most comprehensive model we have to explain the origin of the universe, supported by multiple lines of evidence. However, like all scientific theories, it remains open to refinement and new discoveries. In contrast, a fact is an observation, like the fact that galaxies are moving away from us. The Big Bang itself is not a direct observation, but the best explanation for the facts we have. So while the Big Bang remains a theory, it is a theory that aligns with the vast majority of our observations, making it the closest thing we have to understanding our cosmic origins. The journey of understanding our universe is far from over. Every new discovery brings us closer to uncovering the greatest mysteries of existence. Will we ever know what happened before the Big Bang? Or will we find new theories that change our understanding completely? What do you think? Is the Big Bang the ultimate answer? Or is there more to the story? Let us know in the comments, and don't forget to like and subscribe for more deep dives into the history of the universe.